Hi, it's Mrs. Pound. I'm back with more about minerals. We're studying Chapter 1.2, Minerals in Purposeful Designs, Earth and Space Science. And today's section, 1.22, is about different mineral groups. So our objectives for today are to identify the primary elements in each of several main mineral groups. So we're talking about chemistry here today, and to distinguish mineral groups from each other using their chemical composition and structure. So the first group of minerals we're going to talk about, basically there are two main groups of minerals. There are silicate minerals and there are non-silicate minerals. So we're going to start with the silicate minerals because they are the largest group. These are minerals that are formed by bonded silicon and oxygen atoms, and they make up 90% of the Earth's crust. So this is one big group of minerals. Some examples are feldspar, quartz, mica, and talc. Now, I could not find a picture of feldspar, but here at the top we have mica. It's a flaky kind of mineral that I'll show you in class. There's also quartz, which you're probably kind of familiar with, makes these really nice, pretty crystals. And then this is talc. It's very soft and you can see it looks almost kind of powdery in this picture. So those are some examples of some silicate minerals. And I'm going to switch my camera to show you in your earth science reference tables where you can find some of these minerals. So I switched my camera here, and these minerals, remember, we're looking for silicon and oxygen, and this is on the last page of your reference tables. It says properties of common minerals. There are a lot of properties up here that we're going to talk about very soon. What I'm concerned about is composition and mineral name today. So I'm going to zoom in to that part so we can see that a little bit better. And I'm looking for silicon and oxygen. And as I go down, silicon is Si, so right there, and oxygen O. So silicon and oxygen together, and I have talc, which I showed you, which was that powdery mineral. If we keep going down, oh, right here there's a lot of chemical symbols, but I have silicon Si and oxygen, and I have muscovite mica. So there's that mica. If I keep going down, I spot another one. I'm going to switch over to my pen here. And silicon and oxygen again, and that's biotite mica. So we have our talc and our mica. Let's see, we have down here some silicon and oxygen again, pyroxene. And not always silicon though, sometimes aluminum. Silicon and oxygen here for amphibole. Silicon and oxygen for feldspar, which I'd given you the name of, but don't have a picture. Silicon and oxygen, feldspar again. Silicon and oxygen for olivine. Silicon and oxygen for quartz. And silicon and oxygen for garnet. So if we look even at this list, it's a lot of the minerals on the list are silicates. The rest of the minerals, only about 10%, are non-silicate minerals, but there are a lot more groups here. So it's kind of backwards in a way. Non-silicate minerals are minerals composed of elements or bonded groups of elements other than bonded silicon and oxygen. So it's everything else other than silicon and oxygen, Si and O. So one group are the carbonates. They contain carbon bonded with 3 oxygen atoms. And one example is calcite. And you can see a picture of the calcite in the background there. Switching to my camera to look at our reference tables. So right here, oh, I landed right on it. Carbon and oxygen, that's a carbonate group, CO3, and right there, calcite. Just under it, CO3, dolomite. Okay, and I don't think, are there any others? I don't think I see any others. Those are the only two on our reference tables. So you're looking for that CO3, and that's a carbonate. Another example are oxides. These contain oxygen and one or two metals, and their primary component is oxygen. And one example is hematite. So if we switch over right here, hematite, Fe2O3, hematite. Another oxide right above it with one more iron atom and one more oxygen is magnetite. So that's also an oxide. And I'm looking down through here, probably not any other oxides because most of those have silicon. So a couple of oxides on our list. Okay, we also have sulfates. These contain sulfur and 4 oxygen atoms. And an example is gypsum. So sulfur and 4 oxygen atoms. Let's see if we can find any on our, let's see, I have sulfur here but no oxygen. Sulfur, no oxygen. Sulfur just itself, right? Gypsum I don't even think is on our list, and the reason it is not on our list is because these are common minerals found in New York State for the most part. And so I'm guessing that gypsum is not very common in New York State. So that is not on our list. So a sulfate group is SO4 and not here. So let's move on to the next group, which are our sulfides, because we did see some with sulfur. These contain sulfur bonded to a metal, and an example is pyrite, which is fool's gold. So if I switch over here and I go back to my camera, right here, PBS has sulfur bonded to a metal. Galena is a sulfide. Right here, pyrite, fool's gold, FeS2 is a sulfide, okay? And those two are on our list. Another group are our halides. They contain a halogen in one or more metals. An example is halite, rock salt. So if we go to our reference table, get a little better at switching here. Right here, halite, NaCl, okay? Halogens are chlorine, fluorine, okay? Those are our halogens. So another halite would be here, fluorite, CaF2, okay? That would be halite. Do I see any more? Oh, and another thing to point out is down here, if you're not sure what the symbols stand for, they're right down here, the chemical symbols, so that you know what they are and can decipher these up here. So that is something to help you out. List. Now, native elements are made of only one element. Examples are metals, which are gold, silver, platinum, iron, zinc, tin, lead, and copper. These can be found in nature just on their own. They are minerals that are an element. They're not combined with anything else to be a compound. There are also semi-metals that are found as native elements. They're arsenic and bismuth. And non-metals, carbon, graphite, and sulfur. Graphite is a form of carbon. Okay, so that is a form of carbon. And you also, we did see sulfur. I pointed that out on our reference tables. That is the only native, oh, there was also, I'll switch over and show you that, the native elements. We saw sulfur here, just an S in sulfur. And way up at the top, there was a C, carbon, for graphite. Okay, graphite is your pencil lead. It's also used as a lubricant. Sometimes you put graphite on wheels, like if you're ever in the Pinewood Derby, you put graphite on those wheels to make that go faster, less friction. Okay, so our objectives that we covered today were to identify the primary elements in each of several main mineral groups and to distinguish mineral groups from each other using their chemical composition and structure. I will show you in class some examples of these different mineral groups and minerals, and we're going to be even identifying some of these minerals based on those characteristics that you saw on the reference tables. We're going to be talking about each one of those so that you can use those to identify minerals. Now, don't forget your 5 questions in your margin. And I'll be back more with some of these characteristics.